it would be illegal to use a 12/4 metal-clad cable to provide power to a remote headlight fixture in this manner. The National Electrical Code requires that separate conductors be used for line voltage and low voltage circuits. This is because the different voltages require different types of insulation and protection. In this case, the 12/4 metal-clad cable is designed for use with line voltage circuits. The blue and red conductors in this cable are insulated for 600 volts, which is more than enough for a 120 volt circuit. However, the NEC requires that low voltage circuits be run in separate cables that are insulated for at least 300 volts. If the 12/4 metal-clad cable were to be used to provide power to the remote headlight fixture, there would be a violation of the NEC and potentially creating a safety hazard. The insulation on the blue and red conductors could be damaged, which could lead to a short circuit or electrical fire. The correct way to wire this configuration would be to use a 12/2 metal-clad cable for the line voltage circuit and a separate 12/2 low voltage cable for the remote headlight fixture. The 12/2 metal-clad cable would be connected to the power source and the 12/2 low voltage cable would be connected to the remote headlight fixture. The two cables would then be run to the exit, where they would be connected to the appropriate terminals. Here is a breakdown of why mixing line voltage and low voltage in a single cable like this is problematic. Firstly, insulation ratings are critical. Line voltage, such as 120 volts, and low voltage, such as 6 volts, systems require different insulation thicknesses and materials. The 12/4 metal-clad cable is designed with insulation suitable for higher voltages, but using these conductors for low voltage doesn't negate the risk of potential breakdown if the cable is ever subjected to higher voltage. Secondly, separation of power systems. The NEC mandates separation to prevent interference and ensure safety. Running low voltage and line voltage in the same cable can introduce noise into the low voltage circuit, affecting its performance. More importantly, a fault in the line voltage circuit could energize the low voltage circuit, creating a shock hazard. Thirdly, code compliance. Electrical codes like the NEC are in place to standardize safe wiring practices. Using a cable in a way that deviates from its intended purpose is a code violation and could result in fines, rejection of the installation, and increased insurance premiums. Fourthly, potential for damage. Metal-clad cable offers physical protection, but if the insulation on the low-voltage conductors were to be compromised within the cable, it could be difficult to detect the problem until it causes a fault. This concealed damage poses a significant safety risk. Fifthly, future modifications. If, in the future, someone needs to work on either the line voltage or low voltage circuit, they may not realize that both are contained within the same cable. This can lead to accidental contact with live wires, resulting in serious injury or death. Sixthly, best practices. Even if it seems more convenient to run a single cable, it is always best practice to adhere to established wiring methods. This ensures a safe, reliable, and code-compliant electrical system. Seventhly, consider alternatives. If the goal is to reduce the number of cables, consider using a multi-conductor cable specifically designed for low-voltage applications. These cables have the appropriate insulation and are clearly labeled for low-voltage use. Eighthly, professional consultation. When in doubt, consult a qualified electrician. They can assess the specific requirements of the installation and recommend the safest and most code-compliant wiring method. Ninthly, safety first. The primary goal of any electrical installation should be safety. Taking shortcuts or deviating from established practices can have serious consequences. Always prioritize safety and follow the NEC guidelines. Tenthly, inspections. Electrical inspections are designed to catch code violations and ensure that installations are safe. Using a cable in an unintended way is likely to be flagged during an inspection. By following these guidelines, the risk of electrical hazards can be reduced and ensure a safe and compliant installation. The NEC specifies wiring methods for a reason. It's there to ensure consistent and safe practices. Regarding conductor insulation, the insulation on the conductors within the 12/4 metal-clad cable are rated for 600 volts, which is appropriate for standard line voltage circuits like 120 volts. However, this doesn't mean they are suitable for low voltage applications. The NEC requires that low voltage circuits be run with conductors that are specifically designed and insulated for low voltage use, and that they are separated from line voltage circuits. The reason for this is to prevent the possibility of a fault in a line voltage circuit from energizing the low voltage circuit, creating a shock hazard. Regarding circuit separation, the NEC requires that line voltage and low voltage circuits be physically separated to prevent interference and ensure safety. Running both types of circuits within the same cable violates this requirement. Even though the conductors are insulated, there is still a risk of a fault in the line voltage circuit affecting the low voltage circuit. Regarding code compliance, using a 12/4 metal clad cable for both line voltage and low voltage circuits is a clear violation of the NEC. Electrical inspectors are trained to identify such violations, and the installation would likely be rejected. If a fire or other electrical incident were to occur as a result of this improper wiring, the property owner could be held liable. The NEC provides specific tables and guidelines for selecting the correct type and size of conductors for different applications. These tables take into account factors such as voltage, current, temperature, and environmental conditions. Consulting these tables and following the NEC guidelines is essential for ensuring a safe and code-compliant electrical installation. Always refer to the most recent version of the NEC for the latest requirements and guidelines. Also remember that electrical codes are constantly updated to reflect new technologies and best practices. The 12/2 metal-clad cable is designed for carrying two current-carrying conductors and a ground wire. This is typically used for standard 120 volt circuits. The 12/4 metal-clad cable has four current-carrying conductors and a ground wire. This is typically used for circuits that require multiple conductors, such as three-phase power or multi-wire branch circuits. When dealing with low-voltage lighting, there are specific types of low-voltage cables available. These cables are designed and insulated for low-voltage applications and are suitable for running low-voltage power to remote heads or other low-voltage fixtures. If the desire is to reduce the number of cables, there are multi-conductor low-voltage cables that can be used. These cables have multiple conductors within a single jacket, allowing for the connection of multiple low-voltage devices with a single cable run. An example of this is thermostat wiring. Thermostat wiring is typically low voltage and can be bundled as many wires in one cable. The key is to ensure that the cable is rated for low voltage use and that it is installed in accordance with the NEC. If the desire is to run both line voltage and low voltage to the same location, it's best to run separate cables for each. This ensures that the circuits are properly separated and that the installation is code compliant. When running cables, it's important to follow the NEC guidelines for cable support and protection. Cables should be properly supported and secured to prevent damage. It should also be protected from physical damage, such as being run through conduit in exposed locations. When making connections, use the correct type of connectors and ensure that all connections are tight and secure. Loose connections can cause overheating and create a fire hazard. If unsure about any aspect of the electrical installation, consult a qualified electrician. They can assess the specific requirements of the installation and recommend the safest and most code-compliant wiring method. Working with electricity can be dangerous, so it's important to take all necessary precautions to protect from shock and other hazards. Always turn off the power before working on any electrical circuit and use appropriate safety equipment such as insulated tools and gloves. When running low voltage wiring alongside line voltage wiring, it is critical to maintain proper separation between the two. The National Electrical Code mandates this separation to minimize the risk of interference and prevent accidental contact between the two systems. There are several ways to achieve this separation, one being using separate conduits. Installing the line voltage and low voltage wiring in separate conduits provides a physical barrier that prevents any contact between the two systems. This is the preferred method in many commercial and industrial applications. Another way to maintain separation is using cable trays with dividers. In situations where multiple cables need to be run in the same area, cable trays with dividers can be used to separate the line voltage and low voltage wiring. The dividers create a physical barrier that prevents contact between the two systems. Another method is maintaining a specific distance. If using non-metallic sheath cable, the NEC specifies a minimum distance that must be maintained between line voltage and low voltage wiring. This distance varies depending on the voltage level and the type of wiring used. Another way is using shielded cables. Shielded cables have a metallic layer that surrounds the conductors, providing protection from electromagnetic interference. Using shielded cables for low voltage wiring can help to minimize the risk of interference from line voltage wiring. Another consideration is proper grounding. Grounding is an important safety measure that helps to prevent electrical shock. Both the line voltage and low voltage systems should be properly grounded in accordance with the NEC. Also consider proper labeling. Clearly label all line voltage and low voltage wiring to prevent confusion. This is especially important in situations where multiple cables are running in the same area. As mentioned earlier, always consult the NEC for the specific requirements for separating line voltage and low voltage wiring. The NEC provides detailed guidelines and the methods that can be used to achieve proper separation. Using a 12/4 metal-clad cable for both line voltage and low voltage circuits is not only a code violation, but it also creates a significant safety hazard. It's important to follow the NEC guidelines and use the correct type of wiring for each application. Also, never compromise on safety when working with electricity. It's always better to err on the side of caution and consult a qualified electrician if you have any doubts. The consequences of improper wiring can be severe, so it's important to take all necessary precautions to ensure a safe and code-compliant electrical installation. Metal-clad cable, often referred to as MC cable, is a factory-assembled cable consisting of insulated conductors enclosed in a metallic sheath. The metallic sheath provides physical protection to the conductors, making it suitable for use in exposed or concealed locations. The insulated conductors within the metal-clad cable are typically made of copper or aluminum and are insulated with a thermoplastic or thermosting material. The type of insulation used depends on the voltage and temperature rating of the cable. Metal-clad cable is available in a variety of sizes and conductor configurations. The size of the cable is determined by the ampacity requirements of the circuit. The conductor configuration refers to the number of conductors in the cable and their wire gauge. Metal-clad cable is commonly used in residential, commercial, and industrial applications for branch circuits, feeders, and service entrance conductors. It's suitable for use in dry, damp, or wet locations, depending on the type of cable and fittings used. When installing metal-clad cable, it's important to follow the NEC guidelines for cable support, securement, and termination. The cable must be properly supported to prevent sagging or damage. It must also be securely fastened to boxes and fittings to prevent it from being pulled or dislodged. The terminations must be made with the correct type of connectors to ensure a reliable and safe electrical connection. Metal-clad cable is a versatile and reliable wiring method that offers excellent protection to conductors. However, it's important to use it correctly and follow the NEC guidelines to ensure a safe and code-compliant electrical installation.